All right, Math 20s, this video comes out of lesson 1.5. It's about infinite geometric series. So the last lesson on just geometric series was clearly related. We had some formulas that allowed us to find sums. Now here is another geometric series. I can see that it's geometric because it's multiplying by a common ratio every time. In this case, the common ratio happens to be a half. So just as a review from last lesson, if I was asked to find S10, probably the smartest formula to use would be this guy off your formula sheet. We have term 1, we have the ratio, we have n is 10, so I just substitute those values in. I see when I punch it in that 0.5 to the 10 is actually a very, very small number. My calculator says 9.76 times 10 to the minus 4. So I'll write it, in decimals it's like this, 0.000976. Anyway, notice just that it's a small number, but when I finish the calculation, do my brackets, do my multiplication, do my division, I end up with an answer that's 19.98 something. Now, if I was asked to find S30 of the exact same series, so the same, same first term, same ratio, but now we're letting n be 30, so I use the same formula, let n be 30. If you do that on your calculator, you notice that 0.5 to the 30 is even smaller. In fact, it's very, very small, getting closer and closer to 0, but not quite 0. And so when I do this calculation, I get 19.99999998. Now, as you can imagine, and my apologies here, this should be a 30, not a 100. If I were to do S100 as the next piece of this example, you'd find that your calculator starts to actually round things off for you. In other words, if I change this to a 100 and this to a 100, when you type in 0.5 to the 100, the calculator almost says 0. And the number is so small, I think it's times 10 to the minus 30 something. Anyway, when you subtract the 1 there, your calculator just says minus 1. So basically what's happening is this ratio, when you raise it to a huge exponent, gets closer and closer to 0. So it turns out that we have what's called an infinite geometric series formula. Surprisingly simple formula that just says if you take the first term, so in this case the first term was 10, and you divide by 1 minus the common ratio, you can find the infinite sum. So if I do that in this case, I'll find that I get an answer of 20 exactly. Not too surprising, because I could see from these last two examples that I seem to be getting closer and closer and closer to 20. This only is going to work. This formula only works if your common ratio is between -1 and 1. In other words, the numbers in your geometric series have to be shrinking. Positive or negative, doesn't matter, but they do need to be shrinking in order to add up infinitely many numbers. So as you can see here, I'm adding up smaller and smaller and smaller. So the next number would be 1.25, and then 0.625, and then 0.3125, and so on. And so it makes sense that you could add lots and lots of those and not change your answer. If I had a ratio greater than 1, I'd have a growing geometric series, and there would be no possibility to use this. So this condition here is very, very important. You have to have a common ratio between -1 and 1 to be able to even start to try to find an infinite sum.